Hello dear students, welcome to Pen and Paper Chemistry on YouTube.
Hello dear students, welcome to
Pen and Paper Chemistry.
Thermodynamics part 18. Here we are doing the hopefully last leg of the chapter Gibbs energy and equilibrium constant, the relation between the two and how does it help us to decide whether a particular reaction proceeds in the forward direction, that is whether it will give us a good yield of the products or not. Before we go on, we just need to connect Gibbs energy or Gibbs function to what we have done earlier related to enthalpy and entropy. Standard Gibbs energy of formation, that means the Gibbs energy change when 1 mole of the substance is formed in its standard state from its elements at 1 atmospheric pressure. Now usually temperature is not specified, but in general you will find the data in most of the books related to 298 Kelvin, and for your level it is considered, it is taken practical. Delta GF, Gibbs energy of formation, that is for state other than the standard conditions. Now just like we had done for delta H, that is the total enthalpy of a reaction, is total enthalpy of the products minus the sum of the enthalpies of the reactants, right? If you remember, we had written equations for products and reactants like this, wherein we multiply by the coefficients. Same way we had done for entropy also. If you have to find out the Gibbs energy change for a reaction, we simply do summation of the Gibbs energy change of products minus that of the reactants. Now here, if you remember, again it's an extensive property depending upon the amount of the substance taken. So we will also remember to multiply it by the coefficients, just like we've done in the case of enthalpy and entropy. So if I have m moles of A, n moles of B, x moles of C and y moles of D, the Gibbs energy change for the reaction is given by the number of moles of X into the Gibbs energy formation of, the number of moles of C, which is X, multiplied by the Gibbs energy of formation for C, plus the number of moles of D into the Gibbs energy of D, minus we will have number of moles of A, which I put as M, into the Gibbs energy of A, plus N into the Gibbs energy of formation of B. We put it in brackets just to avoid the confusion related to the sign. Coming to the relation between Gibbs energy and equilibrium constant. Now what is equilibrium constant? Just for easy recall, if you've done chemical equilibrium, if I have a reaction AA plus BB in equilibrium with CC plus DD. Now here, how do we write the equilibrium constant? Now this is just a general expression I am giving. We can do specific study when we do chemical equilibrium. So that is the concentration. Concentration here is moles per liter of the products raised to the power of their coefficients. So that here the coefficient is C, here the coefficient of D is D, divided by the concentration of the reactants raised to the power of their coefficients. This is how we will write equilibrium constant for a reaction. So C to the power C multiplied by D to the power D, A to the power A, B to the power B. Square brackets here indicates the concentration in moles per liter. Alternately, the same thing can be expressed as equilibrium constant in terms of pressure. So we have partial pressure of C raised to the power C, partial pressure of D raised to the power of D, divided by partial pressure of A raised to the power of A into the partial pressure of B raised to the power of B. Either Kp or Kc are used as expressions for an equilibrium constant for any particular reaction. Now we start with the expression delta GR is delta GR naught plus RT natural log of Q. Q is nothing but reaction quotient. That means this ratio at conditions other than the equilibrium conditions. If I am talking about equilibrium conditions, that means my delta G becomes equal to 0. Then the reaction quotient becomes equal to the equilibrium constant either in terms of concentration or in terms of partial pressure, whatever we choose to write. Kc is equilibrium constant in terms of concentration. Kp is equilibrium constant in terms of partial pressure. So delta GR becomes 0. We have delta GR naught plus RT natural log of Kc. Natural log is to the base E. Taking it to the left hand side. Also, we convert the natural log to the base 10, that is the logarithmic tables that we can easily use. You would have them in your chemistry textbooks. You also have logarithmic tables separately provided. So using that becomes quite easy if we convert it to the base 10. So negative delta GR naught is 2.303 RT log of Kc. So this expression helps us to correlate the Gibbs free energy to equilibrium constant. If our equilibrium constant is 1, that means the process is in equilibrium. Kc greater than 1. In other words, our numerator is bigger than the denominator. In other words, our reaction lies more towards the product. The concentration of the products is greater than that of the reactants. Kc less than 1. In other words, the denominator is greater than the numerator. In other words, my reaction is lying towards the left hand side of an equilibrium reaction. In other words, there is less formation of products taking place for such a reaction under the given conditions. So your reactants are greater in concentration compared to the products. And this easily matches with our concept of delta G, where we had said if it is less than 0, process is spontaneous, greater than 0, non-spontaneous, equal to 0, the process is in equilibrium. Hope these set of videos help you to understand thermodynamics a little better. If you feel the benefit, please do subscribe and also recommend it to your friends. Wish you all a very happy time studying chemistry.
The only mission of this channel is to make learning chemistry easy and fun for all you students. With the help of the periodic table, the flowcharts, the graphs, diagrams, dealing with numericals, how to deal with numericals. And this can only happen when you keep a pen and notebook ready so that you can also take down notes for offline reference. There is no subscription to join the channel. There is no payment at all. Only request is to help spread a word about the channel by sharing it with friends, classmates, juniors, seniors, so that chemistry can be easy and fun for one and all. See you in the next video.